Predict the nature of the solute means whether it is undergoing association or dissociation. When this 10 raised to minus 3, you take it to numerator, what it becomes? It becomes 10 to the power 3. Delta TF we know, KF value also we know. Now what is that? It is unknown here. That is molality. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram School of Excellence, Mysore. So today we are back with session 7 of the chapter Solutions. Right, so in the last session we discussed about osmosis, right, and the last colligative property which was osmotic pressure, right, and we also studied about the reverse osmosis and where it is being applied, right, the desalination of seawater, right, and then we studied the last topic of the chapter as well, that was abnormal molar mass, wherein we studied about the Van Hoff factor as well, right. Yes, so in today's session let us solve some numericals based on the colligative properties that we have studied, right? The relative lowering of vapor pressure, depression and freezing point, elevation and boiling point, and osmotic pressure, right? So let's begin with the first question. 200 centimeter cube of an aqueous solution of a protein contains 1.26 gram of protein, right, and the osmotic pressure of such a solution at 300 Kelvin is found to be 2.57 into 10 to the power minus 3 bar, and you have to calculate the molar mass of the protein, right? You have to calculate the molar mass of protein. Let's begin with by writing down what and all is given in the question, right? So 200 centimeter cube an aqueous solution. Yes, the volume of the solution is given as 200 centimeter cube. So 200 centimeter cube, it is how much liters? Yes, it is 0.200 liters, right? Yes, so 200 centimeter cube we converted into liters. It is 0.200 liters. Now what else is given? It contains 1.26 gram of protein, right? So the mass or the weight of the protein is given. How much protein is present? That is W2 is given. 1 stands for the solvent and 2 is for the solute, right? So protein is a solute here. So the mass of the solute is given as 1.26 gram, right? Right. Then the osmotic pressure of such solution at 300 Kelvin. The temperature is given as 300 Kelvin. Okay. And the osmotic pressure is found to be, that is pi. We represent it by the symbol pi, right? It is given as 2.57 into 10 to the power minus 3. Right? So that is the osmotic pressure. Okay. Now, what you have to calculate? The molar mass of the protein. So what is the equation we have to use? It is M2 is equal to W2RT by pi V. Right? We have studied this from the colligative property, that is osmotic pressure, how you can calculate the molar mass, right? So we rearranged the equation and we had studied this equation. M2 is equal to WTRT by pi V. Okay, so what is the R value that you have to use here? It is 0.083. Right? Okay. So, what is W2? W2 is the mass of the solute. Right? Mass of the solute, how much it is? 1.26 gram into R. R is 0.083 into T. What is the temperature? It is given as 300 Kelvin. Right? So, into 300 divided by, what is the pi value? That is osmotic pressure. It is 2.57 into 10 to the power minus 3. Right? Okay. Now what else is there? V. What is the volume? We converted into liters already, right? It is 2.00 liters. Okay. Right. That's it. So when this 10 raised to minus 3, you take it to numerator, what it becomes? It becomes 10 to the power 3. When you take denominator to numerator, the sign changes, right? So finally, when you do the calculation, you get the value as 61022 gram per mole. Okay, so this will be the molar mass of the solute, right? So you substitute the values in the equation W2 RT by pi V, you will get the answer. So this is the molar mass of the solute. I hope it is clear. Now moving on to the next one. 3.9 gram of benzoic acid is dissolved in 49 gram of benzene, right? And it shows a depression in freezing point of 1.62 Kelvin. Now you have to calculate the Van Hoff factor and predict the nature of the solute. And the molar mass of benzoic acid and the Kf value is given here. Okay, so what and all is given? 3.9 gram of benzoic acid is dissolved in 49 gram of benzene. Yes, so the mass of the solute and mass of the solvent is given, right? So what is the mass of solute? Which is a solute here? Benzoic acid, right? So 3.9 gram of benzoic acid is dissolved in 49 gram of benzene. So mass of solvent is 49 gram. Okay, and it shows a depression in freezing point. Yes, the depression in freezing point, what it is? Delta TF, right? Depression in freezing point is given as 1.62 Kelvin. Yes, that is also given, right? Now, what you have to calculate? The Van Hoff factor, which is Van Hoff factor, the I value you have to calculate, right? And predict the nature of the molecule. And what else is given? Molar mass of benzoic acid given. Benzoic acid is what? The solute. So, M2 is given. Right, M2 is given, that is 122 gram per mole. And what else is given? Kf value is also given. Kf is equal to 4.9 Kelvin kilogram per mole. Okay, so these are the given things. Now you have to calculate what you have to calculate? You have to calculate I, that is Van Hoff factor. So what is the equation that we know? Delta TF is equal to I into Kf into M, right? When we add the abnormal mass also to the equation, yes, the equation for depression in freezing point is written as delta TF is equal to I into Kf into M, right? This I is also included. Yes, so what it is that we have to calculate here? It is I, right? We have to calculate I. So, delta TF we know, Kf value also we know. Now, what is that? It is unknown here. That is molality, right? So, how do you calculate molality? Molality is the number of moles of solute which is present in, yes, 1 kilogram of the solvent, right? Number of moles by mass of solvent. Right. How do you calculate number of moles of the solute? It is W2 by M2, right? Mass by molar mass of the solute, right? And what else is there in the denominator? It is mass of solvent, that is W1, right? W1, okay. So now if it is in grams, we have to convert it into kilogram, right? So what do we do? Multiplied by 1000, okay? It's divided by 1000 which comes to the numerator as into 1000. Clear? So that is molality. So how you can write this equation in terms of molality? It will be delta TF is equal to I into Kf into W2 into 1000 by M2 into W1. Okay, right? So now what is that we have to calculate? We have to calculate I, Van Hoff factor, right? So I can rearrange the equation. So I will be equal to delta TF, right? This will be here. Now the denominator comes this side, right? So delta TF into M2 into W1 divided by, so now whatever was in the numerator will come to this side, right? Yes. So it will be Kf into W2 into 1000. Okay, that's it, right? I just rearranged the equation. So how you can calculate it now? What is delta TF? Delta TF value is 1.62, right? So 1.62 into, what is M2? M2, yes, it is 122. Molar mass of the solvent is given as 122 into W1. What is W1 here? Yes, mass of the solvent is 49, right? 49 divided by, what is here? Kf. What is the Kf value? 4.9, right? Kf is 4.9 into, what is W2? Mass of the solute. It is given as 3.9, right? 3.9 into 1000, right? So, I hope it is clear. So, finally, when we do this, we get the answer as I is equal to 0.507. Okay. So, we calculated the Van Hoff factor, right? So, there is one more part for the question, and predict the nature of the solute. Yes, predict the nature of the solute means whether it is undergoing association or dissociation. So, we got the I value. It is 0.507. Is it less than 1 or more than 1? It is less than 1, right? Our I value is less than 1. So, in the last class we discussed when the I value is less than 1, what is happening to the solute? The solute particles is undergoing association, right? The solute particles are undergoing association. Okay. So, what is the nature of the solute particles? They are undergoing association, right? So if it was greater than 1, it undergoes association, and if it is equal to 1, it neither undergoes association nor dissociation. Okay, so in this case, as the I value was less than 1, the solute particles are undergoing association, right? So I hope it is clear. Now moving on to the next question, that is, calculate the boiling point elevation. You have to calculate the elevation in boiling point for a solution prepared by adding 10 gram of CaCl2, calcium chloride, to 200 gram of water, and the Kb value and the molar mass is also given. Okay, you have to calculate the elevation in boiling point, that is delta Tb you have to calculate. Now what and all is given here? Okay, for a solution prepared by adding 10 gram of calcium chloride, right? So W2 is given as 10 gram, okay, to 200 gram of water, right? W1 is also given, that is 200 gram, right? That is mass of the solute and mass of the solvent is given here. Now Kb is given as 0.52 Kelvin kilogram per mole, and molar mass is also given. That is, molar mass of what is given? Molar mass of calcium chloride is given, right? So M2 is given as 111 gram per mole. Okay, so these are the given things. What is that you have to calculate? You have to calculate delta Tb. So we know that delta Tb, how you can calculate? Delta Tb is equal to I into Kb into M. Right, see, when we are including the Van Hoff factor, the equation becomes delta Tb is equal to I into Kb into M, right? So now we have to calculate delta Tb. We know the Kb, we can calculate molality. How do you calculate molality? Molality, same way, number of moles present in mass of the, that is 1 kilogram of the solvent, right? So it is number of moles divided by mass of the solvent, right? So what is the number of moles? W2 by M2. Mass by molar mass of the solute. Yes, now what else is in the denominator? Yes, mass of the solvent, that is W1, and into 1000, right? Because it is given in grams, right? Masses are given in grams, so you need that 1000. So this way you can calculate the molality. So how does the equation becomes? It becomes delta Tb is equal to I into Kb into W2 into 1000 divided by M2 into W1. Our equation becomes like this, right? So now all these values are known except I. So how do I calculate I? In the question, yes, the solute is given, it is calcium chloride, right? So calcium chloride. Okay, so in the solution, how does it dissociate? It dissociates into Ca2 plus and 2Cl minus. Okay, so calcium chloride dissociates into Ca2 plus and 2Cl minus, right? 2Cl minus charges is required, right? Because 1 Cl carries 1 negative charge. So to balance this 2 is required here, right? So the calcium chloride dissociates into Ca2 plus and 2Cl minus. Okay, so how you can calculate I from this? I will be equal to the total number of particles into which it has dissociated, right? So in this case, there is 1 Ca2 plus and 2 Cl minus. So a total of 3 particles it has been dissociated into. So our I value will be 3. Right. So here there is no coefficient, that means 1 Ca2 plus and 2 Cl minus, that means 1 plus 2, 3. So our I value will be 3. So I hope if the solute is given, how you can calculate the I value, it is also clear for you, I guess. Right. So now how I can write the equation? It is 3 into, right, the I value is 3. Okay. Into Kb. What is the Kb value? It is given 0.52. Into, what is W2? W2 is 10 gram into 1000 divided by, what is the M2? M2 is given as 111 into W1. W1 is 200, right? Okay. So when you do the calculation, you get delta Tb as 0.702 Kelvin. Right? So that is the value for delta Tb. So I hope it is clear, right? So we used this equation, delta Tb is equal to I into Kb into M. We know how to calculate molality. How we calculated the I? We saw the CaCl2, how it dissociated. It is dissociating into Ca2 plus and 2Cl minus. So a total of 3 particles it is getting dissociated into. So your I value will be that value. Clear? Right. Now moving on to the next question. The vapor pressure of pure benzene at a certain temperature is 0.850 bar. Right. And a non-volatile, non-electrolyte solid weighing 0.5 gram is added to 39 gram of benzene, which is having a molar mass 78 gram per mole, right? And the vapor pressure of the solution then is 0.945 bar. Right. Now, what is the molar mass of the solid substance? You have to calculate M2, right? Molar mass of the solute you have to calculate. So, what and all is given? Let's write down first. The vapor pressure of pure benzene, right? So, the pure solvent, what is the vapor pressure? It is given. So, what it is? P1 naught, right? For the pure solvent, P1 naught is given. What is given? 0.850 bar. A non-volatile, non-electrolyte solid weighing 0.5 gram. So, what is given? Mass of the solute is given, right? So, W2 is given as 0.5 gram, right? It is added to 39 gram of benzene. So, yes, the solute, the mass of the solute and mass of the solvent is also given. That is W1 is equal to 39 gram of benzene. Right. Now, the molar mass of the solvent is also given. Molar mass of the solvent, that is M1 is given as 78 gram per mole. Okay. What is it that we have to calculate? It is M2, right? M1 is given. Now, vapor pressure of the solution then is 0.945. Okay. When we added the solid into the pure solvent, the vapor pressure changed, right? So, the vapor pressure now it has become 0.945 bar. So, that is P1. Right. Initially, it was P1 0 that is given and P1 is also given. You have to calculate what? M2 is that. You have to calculate M2. Okay. So, what is the equation that we know? P1 naught minus P1 divided by P1 naught. See, relative lowering of vapor pressure is the colligative property that we are talking about here, right? It is talking about the lowering in vapor pressure, right? So, P1 naught minus P1 divided by P1 naught is equal to W2 into M1 divided by W1 into M2, right? Okay, W2. Yes, we know that relative lowering of vapor pressure is equal to the mole fraction of the solute, right? So, how do you write it? Mole fraction of the solute is W2 by M2. That is number of moles of the solute divided by number of moles of the solvent plus number of moles of the solute, right? So, when we are considering dilute solutions, we do not consider N2 in the denominator. We discussed this in last class. So, W2 by M2 divided by number of moles of solvent. Right. So, if I am taking this to numerator, the equation becomes like this, right? W2 into M1, this M1 comes on top, divided by W1 into M2. So, this is the equation you can use, right? So, what is P1 naught? P1 naught is 0.850 minus, what is P1? 0.945. 0.945 divided by P1 0 again, that is 0.850. This is equal to, what is W2? W2 is 0.5. 0.5 into M1 is given as 78, right? 78 divided by W1. What is W1? W1 is 39, right? 39 into M2, right? So, you have to calculate M2, right? So, we can rearrange this equation. So, how does it become? M2 will be equal to, right? This comes here, that is 0.5 into 78 divided by 39 into this term comes, the whole terms comes here, right? So, it becomes 0.850 minus 0.945 and this comes in the denominator, so it goes to the numerator, right? So, into 0.850. So, if you do the calculation, what you will get? You get M2 as 170 gram per mole, right? So, this is the molar mass. Okay. So, from relative lowering of vapor pressure, how you can calculate molar mass, it is clear for you, right? Now, moving on to the next question. The boiling point of benzene is 353.23 Kelvin. Okay. Now, when 1.80 gram of non-volatile solute was dissolved in 90 gram of benzene, the boiling point is raised to 354.11 Kelvin. Okay. Yes. Now, you have to calculate the molar mass of the solute. Kb is given here. Right. So, the boiling point of benzene is 352.23. Right. Before adding the solute to it, that is of the pure solvent, it is given. Right. So, the boiling point, that is TB naught is given as 352.23 Kelvin. Right. Now, when 1.80 gram of non-volatile solute, the mass of the solute is given as 1.80 gram. Right. It is dissolved in 90 gram of benzene. So, mass of solvent is also given 90 gram. The boiling point is raised to 354.11. So, now TB is also given. Right. Initially, that is for pure solvent, it was this value. Now, when the solute is added, that is for the solution, the boiling point, what happens? The boiling point is elevated, right? So, that value will be 354.11 Kelvin. Okay, right? Now, what you have to calculate? The molar mass of the solute. You have to calculate M2, right? And the Kb is given as 253. Kb is given as 2.53 Kelvin kilogram per mole. The Kb is also given. Right. So, these are the given things. Now, what you have to calculate? The molar mass of the solute. So, what is the equation that we know? Delta Tb is equal to Kb into M. Right. Delta Tb is equal to Kb into M. Okay. So, how do you write molality? Molality is W2 by M2, that is number of moles, divided by mass of the solvent. Right. So, you can write it as W2 divided by M2 into 1000. Right. Yes. And W1 will be here, that is mass of the solvent, right? So, if the mass of the solvent is in gram, we need to convert it into kilogram, right? So, that's 1000 is required. Okay. So, what is it that we have to calculate? It is M2. So, I rearrange the equation, right? So, M2 will be equal to, right? M2 will be equal to Kb into W2 into 1000 divided by W1 into this delta Tb comes here. Right, this is the equation. So, we have studied this equation also. Directly how you can calculate the molar mass. Directly you can use this equation instead of starting from here. Right. So, this is the equation. Okay. Now, Kb, W2 and W1 is known. Now, what about delta Tb? It is not given here. But the initial and the final boiling point is given. That is the boiling point of the pure solvent and the boiling point of the solution is given here. Can you calculate delta Tb? Yes. Delta Tb, how you can calculate? It is Tb minus Tb naught, right? Elevation in boiling point. For the solution is having higher boiling point. So, what is Tb? Tb is equal to 354.11 and Tb naught is 352.23. Okay, so you take the difference, it will be 0.88 Kelvin, right? So, that is delta Tb. So, that you can use here. So, the equation becomes, what is Kb? 2.53 into W2 is 1.80 into 1000 divided by, now what is W1? W1 is 90. 90 into delta Tb value is 0.88, right? So, once you do the calculation, you get the answer as 58 gram per mole. So, that will be your molar mass of the solute. Clear? Right. Now, moving on to the last question. Yes, 45 gram of ethyl alcohol, right, is mixed with 600 gram of water. Now, you have to calculate the freezing point depression, that is depression and freezing point, and the freezing point of the solution also you have to calculate. And the Kf is given here, right? You have to calculate freezing point and the, yes, depression in freezing point and the freezing point of the solution. That is, you have to calculate delta Tf as well as you have to calculate Tf, right? Yes. So, let's see. 45 gram of ethyl alcohol is mixed with 600 gram of water. So, what's the solute here? It is ethyl alcohol, right? So, W2 is given as 45 gram, right? It is mixed with 600 gram of water. So, solvent is water, W1 is 600 grams. Okay, right? So, now you have to calculate the freezing point depression. Yes, you have to calculate delta Tf. How do you calculate it? It is Kf into M, right? It is Kf into M. So, what is the M? Kf we know. What about the M? Molality is not given here. You have to calculate it. So, molality is number of moles by mass of solvent, right? Number of moles by mass of solvent. So, that is equal to W2 by M2 into 1000 divided by W1. W1 is the mass of the solvent and 1000 because it is given in grams, right? What is W2? W2 is 45. Now, what about M2? That is mass of the solute. How do you calculate? M2, is it given here? No, you can calculate C2H6O2. So, that is 12 into 2 plus 6 plus 16 into 2. So, what is it? So, that is equal to 62 gram per mole. Right. So that is the molar mass. So that 45 divided by 62 into 1000 divided by what is W1? It is 600 grams. Right. Yes. Okay. It was 600 grams. So I use the 1000 as well. So what did we calculate here? It is delta TF. Right. So once we do the calculation, you get the TF value. How you can do the calculation now? It is delta TF is equal to KF into M, right? So how the equation becomes? What is KF here? KF is given as 1.86. 1.86 into 45 divided by 62 into 1000 divided by 600, right? So if you do this calculation, you get your delta TB as 1.2 Kelvin, right? You get the answer as 1.2 Kelvin. Now that is delta TF, right? Now we calculated the depression and freezing point, that is delta TF. So now one more thing you have to calculate, that is the freezing point of the solution, right? So we know that delta TF is equal to, yes, TF naught minus TF, right? It is TF naught minus TF. So what was the freezing point of the pure solvent? That is, it is a water, right? What is the freezing point of pure solvent? It is 0 degrees Celsius. So 0 degrees Celsius in Kelvin scale, it is 273.15, right? Yes, in Kelvin scale, it is 273.15. Now minus TF, right? Minus the TF will give you what? Delta TF. That is what we calculated here, 1.2. So how I can get TF from here? TF will be equal to 273.15 minus 1.2. Right? So my answer is 270.90 Kelvin. Right? So that is the TF value. That is the freezing point for the solution. Yes, I hope it is clear. So what did we begin with? Delta TF is equal to KF into M. We calculated the molality. Right? We calculated the molality, number of moles by mass of the solvent. We calculated the molality. So that gave you the delta TF value. That is delta TF is equal to KF into M. From that you calculated the delta TF value as 1.2. Now delta TF is equal to TF naught minus TF. What is it that we have to calculate? It is TF, right? Freezing point of the solution. So, delta TF is equal to TF naught minus TF. We know delta TF and we know TF naught as well. That is for the pure solvent. Yes, pure solvent, that is water. What is the freezing point? 0 degrees Celsius, right? So, in Kelvin, it is 273.15. Right? So, when we take it to the other side, we get TF. That is the freezing point of the solution as 270.90 Kelvin. Right? So, I hope the colligative properties and the numericals that we discussed in this session is clear for you. So, that is the end of this chapter. So, in the next session, we will meet with you with a new chapter. That is the chapter 2, that is electrochemistry. Right? So, that's all for today. Thank you.